So first off, I'd like to thank Sate, Chris, Dan, and Joan, and other associates who've made this possible today. We're really excited to present our project in kind of a unique format. My name's Julian, and today I'll be presenting alongside Raphael and Spencer, and we'll be going over our project MindSphere. So just a quick little agenda here. We'll be covering our problem statement, going over scope and constraints. Spencer will cover the research. Raphael will cover the function analysis, among other details, and we'll end with a conclusion and a Q&A at the end. So the problem statement is as follows. The mechatronics lab at SAIT wants us to find a method of collecting energy consumption information from all the devices in the lab and monitor that data from a single dashboard. The system must monitor pneumatic and electrical usage for each device, and specifically each motor on the ABB robots. So a bit about our scope here. We'll be capturing the data specifically from the PLCs and ABB robots in the lab. Although this project can be scaled out to capture much more, this will be focused on this semester. The data also has to be useful, so we won't be collecting other things except for energy usage at the moment. And it'll all happen within the semester, 3-month period. So quick cover of the constraints here. The number one constraint for us is financially. Some of the software can be quite expensive. Luckily, SAIT has access to some of them already. But for example, some of the drivers that might make this project a little bit easier can be quite expensive and require a membership fee that we need permission for. Time, obviously, lab time, being the project mainly collecting all the data in the lab. We have a short amount of time to get everything done, so we need to plan everything and execute it in that lab time. And again, semester. So environmental, obviously, this kind of crosses over with the time. So the lab access is the biggest part. Obviously, everything digital, and with COVID-19, luckily SAIT has granted us access with the right protocol to the lab. But that's kind of our biggest hurdle. And at this point, I'd like to pass it off to Spencer to cover some of the research we've covered.
So some of the solutions that we have looked at were ABB Ability Solutions and Rockwell Automation. And they both have solutions for collecting and monitoring real-time data, as well as for predictive maintenance. And these solutions, they have platforms available for developers. And there's not many companies that are able to create and sustain a developer platform. So we feel that having that capability, it really pushes these competitors ahead of the others. So ABB Ability, ABB has created their own solutions catalog, and they called it ABB Ability, and they have many different solutions available for monitoring and predictive maintenance. And they're always looking to improve for the future, which definitely makes them one of the best options available. And Rockwell Automation also has a variety of solutions, and there are different software and hardware devices available so that you can find many different ways of gathering the data and monitoring it. And now I'll just take you through some of our requirements for our project. So we have a few demands as well as some wishes. And the wishes we are not expected to complete, but we hope to implement them into our project later on if time allows us to. And so for our first demand, we will be gathering the voltage and current readings from the PLCs as well as from the individual motors on the ABB robots. And we hope to connect other devices as well so that we can prove the scalability of our project. And we will be using MindSphere to create an application in order to visualize the data that we are collecting and so that we can display it onto a single dashboard system. And afterwards, we will be creating a documentation for our clients so that they can understand how to connect devices to KEP server and also how to access and use the data that is being displayed effectively. And we hope to implement predictive maintenance using MindSphere, but that is not a necessary requirement. We just hope to achieve that later on if time allows for that. So now I'll pass it on to Raphael, and he's going to be going over our morphological chart.
Hi, so for our research, we used YouTube, KEP server product manual, an IRC5 controller manual. We emailed support and PLC manuals. For our drivers, we used an OPC DA protocol, which is a client for gathering data from devices. And hopefully we'll implement the OPC UA protocol as well, which is a lower bandwidth option. Data transfer, we used robots. We're using Robot Studio as well as KEP server to track and mine the data. And then we'll use MindSphere with MindSphere's developers tools to create the UI that will be displayed on the monitor. Next, please. So by using Kepler, we're going to mine the data, and once we have all the IOs and the energy readings, we will transfer it to MindSphere, which will be displayed on the dashboard outside of the lab. Next, please. So these are some of examples of devices that we're going to use to get energy readings from, like the ABB robot arm, which has 6 motors that we're going to be tracking, as well as an MPS station, which is a mechatronics training station that we'll be getting the energy from the processing of the PLC, and the trainer, which will also be getting energy from these trainers. Students use those to practice PLCs. Next, please. So for KEP server allows us to connect to different processes and hardware, like PLCs, computer flow, database, and sensors and actuators as well, using the OPC server, which is the client that will be mining the data from those devices. I'll give it to Julian from here.
So some of the applications you might see KEP server being used obviously are displayed in front of you. It's quite versatile. In our case, it's going to be skewed towards manufacturing. Moving on to MindSphere. So MindSphere is a phenomenal product that allows users to analyze and manipulate asset data that we've collected. So for instance, you are able to use different variables and cross-reference them to create a dashboard where the user can see relevant data. So you're not seeing data points that don't make any sense to you. For example, this is kind of a screen clip of the visual analyzer tool that MindSphere makes available to its users. You were able to select different machines, different data points, and cross-reference them to get appropriate data, which is, it's really cool, and the whole platform is really user-friendly. This is my favorite part. This is MindSphere's visual flow creator. So once we've collected all the power and data points that we find relevant, you're able to select and create a flow chart to create the dashboard. So it's really user-friendly and requires little programming experience. So in our case, in this example, you're going to see time with cross-reference with a motor current among, and you're able to choose your chart among other details here, and it will produce a dashboard as the following. So this is a neat dashboard that is hopefully the end goal. It's really clean, and someone's able to look at it and make use of that, what's being displayed. So again, current over time or instantaneous current is what's required of us. And this is just kind of an example of the MindSphere dashboard being used. So in conclusion, our group will be using KEP server to mine data from the PLCs and individual motors on the ABB robots in the lab, as well as use MindSphere to make sense of that data, display it on a dashboard in the lab. At this point, I'd like to thank everyone for listening. We are personally really excited about this project, and we're open to anyone's questions.
I've got a couple to start off. My first one was, what type of sensors or other parts may be needed in order to look into how you're collecting the power usage or the amperage from the motors? Is there's another sensor or something you're gonna have to hook up, or is it all collected within the motor that you can mine through MindSphere?
Sorry, well, most of the we're mostly able to connect through a OPC UA or DA connection through Ethernet IP. And if it doesn't have that capability, you might need a sensor or something, which you are able to get them from ABB. They have a lot of those available, and other companies as well have them available too.
Okay.
In our case, hopefully we won't have to implement a sensor. We're just mining the data that's available to us.
Okay, fair. My second question, you guys had brought up trying to do predictive maintenance on these motors. I know you said it was a wish, but because it's in your scope, I'm going to ask about it.
Yep.
What would be the things you'd look for, me coming from a maintenance standpoint? What kind of jolts in the graphs or what kind of surges would you be looking for in order to say, hey, this motor needs to replace, or hey, this needs to be looked at?
So when we're looking at basically energy consumption, the main things that Chris and Dan had brought to us were oil changes and stuff. And because in the lab there isn't continuous use, the defined oil change schedules by the manufacturer don't necessarily apply. So what we would look for in the information that we're trying to cultivate are maybe a trend line of an increase in power consumption, which could indicate that the machine, specifically the ABB robot arm, would have more trouble engaging its motors, therefore dictating that the oil is thick or might need to be changed. There are also alerts and stuff that you can set in MindSphere, and we're just kind of leaving that open to be scaled out potentially by later years. But only using the energy data collected, we would look at increase in energy consumption.
Okay, thank you.
You're welcome. Any other questions? All right, thank you so much, everyone. And I'll start ending this.